So in this problem, we need to obtain the derivative of inverse tangent of square root of 1 plus x squared minus 1 divided by x with respect to tangent inverse of x. To find out this derivative, all we have to do is make an assumption. We'll consider u as a function of x equals to inverse tangent of square root of 1 plus x squared minus 1 divided by x, and v be another function which will be given by inverse tangent of x. Right. So all we have to do is find the derivative of u with respect to x and derivative of v with respect to x. Right. So this will be equivalent to finding du over dv. Okay, let's begin. Now here what we'll do, we'll have to make another assumption in order to simplify u of x. All we'll do, we'll make an assumption that let x be equals to tangent of theta. So if we take x to be equals to tangent of theta, then we will have inverse tangent of, so here we have square root of 1 plus tangent squared theta. All we have done is replace the value of x with tangent of theta minus 1 divided by tangent of theta. So that gives us tangent inverse of, so we have square root of 1 plus tangent squared theta, so that's secant squared theta, and we take the square root minus 1 divided by tangent of theta. Further simplification gives us inverse tangent of, so we have secant squared theta square root, so that will be secant theta minus 1 divided by tangent of theta. Now converting secant theta to cosine theta, so we have 1 over cosine of theta, so that's the reciprocal of cosine theta, minus 1 divided by, we have tangent of theta. The tangent of theta is simply the ratio of sine over cosine. So we have tangent inverse of 1 minus cosine theta divided by sine theta. Now what we'll do, we'll have to make use of an identity. We know that cosine of theta, so that's given by 1 minus 2 sine squared theta over 2. So that means 2 times sine squared theta over 2 will be equals to 1 minus cosine of theta. Or we can replace 1 minus cosine of theta in the numerator with 2 times sine squared theta over 2. And sine theta is also given by 2 times sine theta over 2 times cosine of theta over 2. So that means we now have divided by 2 times sine theta over 2 times cosine of theta over 2. So this is the argument of the inverse tangent function, and this is our u of tangent of theta, or simply u of theta, u as a function of theta. So this will be equals to inverse tangent of, so here the 2 and 2 goes away, 1 sine theta from the numerator and the denominator goes away. So we have sine theta over 2 divided by cosine of theta over 2. So the ratio of sine over cosine, so that's inverse tangent of theta over 2. Now tangent inverse of tan theta over 2, that simply gives us theta over 2. So this is u of theta. Now again, we coming back to our original x. So we have u of x will be given by a half. So we considered that tangent of theta is equals to x. So that means theta will be equals to tangent inverse of x. So this is simply tangent inverse of x. So u of x now simplifies to half of tangent inverse of x. Now we can simply take its derivative with respect to x. So we have derivative of u with respect to x, that simply equals to half times derivative with respect to x of the inverse tangent function. The derivative of the inverse tangent function is 1 over 1 plus x squared. So we get derivative of u with respect to x equals to 1 divided by 2 times 1 plus x squared. Let's label this as number 1. Now going back to the value of v, so we consider v of x to be inverse tangent of x. So we have v equals to inverse tangent of x. The derivative of v with respect to x will be equals to 1 over 1 plus x squared. This is number 2. Since we will have to find out du over dv, that is simply derivative of u with respect to x divided by derivative of v with respect to x. That means we'll divide 1 with 2, and that leaves us with the value half. So this is the derivative of the given function with respect to v, where v is inverse tangent of x.